How did I get? I think someone muted my microphone because I was not mute. After I finished speaking with Mayola, I just went straight into the business of the day. So I don't really think that. I don't think I don't know. Okay, so let me get started all over again. So I started by talking about some of those things that we did last week. So last week we had introduction into big data analytics, where we considered the elements. What are those things that constitute big data analytics? What are the how has big data analytics evolved from maybe analog data collection to what we have today as sophisticated data mining and data management techniques. Then we also talked about some other elements of big data in terms of the volume of the data, the value of the data, and the variety in which the data comes. We said that those are some of the things that define big data as big data. We also talked about some other classification of big data in terms of whether the data is big or the data is small, or whether the data is structured or whether the data is not structured. There are so many types of classification of data, and another one is maybe the data is a string data, or whether the data is a number, or whether the data is a date or a time data. So all of these to have different applications, they require different tools. And also remember that we also spoke last week that in order to perform analytics on big data, one of the basic elements that you need, or the most fundamental building block for generating analytics, number one is the data. Just the way you need animal for animal science, you need data for data science. Then the next consideration would be the technology and the tools, for managing big data. And the third part will now be the domain competence, or how the know-how on how to manage those tools. And I like giving this example, and I don't think I can cease giving this example. And it's the fact that there are different tools that are best fit for different type of data sets. Even though it's Python may not be fit for some kind of operation where R will be best fit for it, and R will not be best fit for some kind of solutions, analytic solutions, where R will not be useful, where R would probably work very fine. So it's like when you have a car broken down on Third Mainland Bridge and you want to tow that vehicle, you can actually use an ambulance to tow a car that broke down on Third Mainland Bridge. But the fact is that an ambulance is not designed to tow a vehicle, even though you can manage to use it to tow a vehicle and it will take you to the destination. It's a towing van that is best fit. Say there is an accident scene on Third Mainland Bridge, you can decide to use a towing vehicle to quickly rush the victims of that accident to the nearest healthcare center or the nearest hospital. But in the real sense, a towing vehicle is not really proper, it's not built. That is not the purpose for towing vehicle, even though you can use it to achieve that purpose. So the same way in data analytics and big data generally, there are different tools that are required for predictive modeling, for descriptive modeling, and for prescriptive modeling. So the understanding of these tools, the understanding of the tools, the understanding of the domain, and the understanding of the type of data that you are working on is really going to go a long way to give you leverage in how you exercise your data analytics skill. Then I think last week we closed on, last week we also had several applications of big data across different industries. There's no how we would take this course without really making references to applications of big data in insurance, in oil and gas, in banking, in sports business. Just think about it. Just think about it. And I think the other time when I was meted, one of those things that I talked about is the fact that for me as a sales officer in Octave Analytics, what I do essentially is to look for different applications of big data. We are going to be talking about some of them today. So I can just pick an industry, I can just pick a government parastatal, I can just pick maybe CBN, and then I start imagining how can I apply big data and analytics within the operations of Central Bank of Nigeria. I can look at Nigerian statistics, NBS, Nigerian Bureau of Statistics, and then say, okay, how can I apply big data in the operations of the guys in Nigerian Bureau of Statistics? Then you can just think about anything, then think about use cases, very valid use cases for the applications of big data to those different industries. That is, those are some of the applications of big data. And we ended last week talking about descriptive analytics, predictive analytics, and prescriptive analytics. And I spent a lot of time, honestly, I didn't know I was muted. Some very valid stuff that I said while the microphone was muted. When you talk about this, so in the different approaches to analytics, one is descriptive analytics, where you are looking at data in historical perspective. What has happened in the past? How much did I sell yesterday? How much did I sell last week? How much did I sell yesterday compared to what I sold on Thursday last week? So just looking at data in historical perspective, explorative data analytics, or looking at data in terms of what is happening now, that is data exploration. Then you also have the predictive analytics, where you use what has happened in the past. Please mind my word. You use what happened in the past to determine what would likely happen in the future. That is predictive analytics. Then you also have prescriptive analytics, where you look at what has happened in the past and you predict what will likely happen in the future, and then you are recommending the next best course of action, to maximize, the options, the predictions that you have made. So when you look at, when you see people who build models or people models, they spend a lot of time doing descriptive analytics, even though what they are building is predictive modeling. But the fact is that they are using what has happened in the past to tell what will likely happen in the future. So they are 100% going to be interested in what has happened in the past. So in trying to build the model for what has happened in the past, you spend a lot of time. In trying to build the model for what will happen in the future, you spend a lot of time, discovering the data for what has happened in the past. So predictive modeling has a high component of descriptive analytics in it. Then when you move to the next trend, which is prescriptive analytics. Prescriptive analytics is trying to make recommendations. What should you do? For you to know what you should do, you need to know what is happening or what is likely going to happen. And for you to know what is happening or what is likely going to happen, you need to know what has happened before. So you can see that even prescriptive analytics will require descriptive analytics and predictive analytics before you can conclude that this is the best course of action to take at a particular point in time. So that is how, those are the different approaches to big data analytics. The applications, there are so many applications to this in transportation, in education, in travel business. I gave an example earlier on that in a company like MTN has like 4 senior managers analytics, four different senior managers analytics. So when you go to network group is a different division. There is manager analytics, senior manager analytics. The guy's name is Kelechi. If you go to enterprise solutions, it's another department that is headed by Chief Enterprise Solution Officer, CESO. That there is a senior manager analytics that is headed by a guy whose name is Dr. Olu. If you come to marketing department, in fact, marketing department has like two managers analytics and one senior manager analytics, Basi. If you go to sales and distribution department, which is also headed by another executive, there's a senior manager analytics, and in fact, there's a general manager analytics, and that department is headed by Nosa or something. So when you look at it, the same entity, the same company, but because there are different operations within that one single company, they have different heads of analytics, because the marketing requirement for analytics is different from the sales requirement from analytics, and different from network group requirement from analytics. And that shows that is a company that actually values the application of data and analytics within what they do. The same way when you come to transportation business, government business, travel, analytics is the analytics is all applicable in all of this. Yeah. So I think before Tokwe called my attention, I was talking about having a career in big data. That it's no limit to the industries that require the services of a big data practitioner or data science practitioner. There is no limit. If you go to insurance underwriting, or insurance sales and marketing, or insurance claims management, you need analytics. So to determine whether a claim is fraudulent or not fraudulent, you need analytics. To determine whether the business you want to underwrite, whether it's a good business or it's not a good business, you need analytics. Then also, I've given you telco example. Also in banking, there's a bank, Access Bank. Access Bank, in their IT department, they have a manager in charge of analytics. My former colleague, I can't remember his name now. Arize, yes, Arize. Then also, if you go to finance department, in finance department, there's a manager analytics in finance department. Her name is can't remember her name. So what I'm saying in essence is that businesses are beginning to see the value of data science, the value of data analytics, and they begin to see the reason why they should harness a lot more value from the kind of data they generate. So there is no limit to the industries for which you can apply your skill as a data scientist. Now, as a data scientist, what are those skills that are required? Remember when we were talking last week about domain know-how. When we talk about domain know-how, we said that there is the need to understand the tools. There's need to understand the tools, the data science tools or the analytics tool, and there's also need to also understand the domain itself. So and the MTN example that I gave is because there are different domains. The marketing domain is different from the sales and distribution domain, and it's different from the enterprise solution domain, and it's different from the network group domain. So they have come to see that, so if we rely on maybe just one single data scientist, because that single data scientist, he may be an expert in maybe marketing domain, he may not be able to service the guys in network group properly. So because of that, each of these different departments decide to appoint their own data scientists who would specialize in the domain for which they were recruited for. So for big data analytics, so in terms of technical skill, of course, you need to have some programming knowledge, whether it is SQL or Python or R or MATLAB. You need to know how to do some basic level of coding or to be able to interpret. Even if you are a senior manager in a tech or in a bank and you don't have time for, I would say they don't have time for that rubbish again. They don't have time for any kind of coding again. Well, maybe not a problem, but you need to be able to interpret a line of code and know exactly what it does. Then you also have the understanding of big data architecture, big data environment itself, like Hadoop, Hive, and MapReduce. Of course, we are going to be getting into all of that sometime very soon. Then you also need some basic knowledge of maybe natural language processing. So when you are dealing with unstructured kind of data set, you are extracting data from Naira land or you're extracting data from Twitter, those data sets, they are written in natural language. They are not written in SQL or Python. So how do you process them? Then you need to understand machine learning like demand forecast, random forest, demand forest, or support vector machine, regression, and all of those jargons. Please, before now, they used to piss me off, but please don't let them piss you off. I think before 2015, they used to piss me off when people say machine learning, because I was thinking maybe machine learning is about robotics, where you have to program a device, to mimic a human intelligence. But really, at times, it does not really need to get to that level of robotics, before you can actually apply big data big data analytics. Then you also have predictive modeling. Of course, machine learning is a component of predictive modeling. Then you also have conceptual modeling. So some of the guys in some of our projects that we do in FCMB, for instance, some of you already write predictive models. You also write conceptual model. Like RGS is a conceptual model. It's not really a predictive model. We also do statistical analysis. So you also need to have some basic understanding of statistics, combination and permutation and standard deviation and t-test. You really need to know how some of these things, how they work, because these are also the elements that are coded into the machine learning algorithm. Then beyond that, there are some soft skills that are required as a data scientist or as a big data professional. And one of them is you need to really know how to communicate data in a way that a layman would understand. Because yeah, you might be writing Python and SQL code, or you may be writing demand forecast or random forest. You may be writing decision trees. But the fact is that if you are talking to the MD of say Central Bank of Nigeria, if you are talking to the governor of Central Bank of Nigeria, he does not know what random forest is. He does not know what decision, but what he knows is inflation rate. So the fact that your model, what is your model predicting? Your model is predicting that inflation will drop by maybe 1% or by 2%. Yeah, that is what he understands. He does not understand whether it is Python that he used to write it or whether it is SQL. So you need to know how to communicate, your technical skills to come to an average person that does not have those technical skills. You need to know how to query databases. Those are not really soft skills per se. To know how to query databases is not a soft skill, but maybe DASCA is classifying it as a soft skill. You need to know how to develop programs, databases. You need to know also how to advise senior management. So at times, the senior management, they tend to feel that they know more than you because they sit in that senior management position. But because you see the data, so you need to know how to really negotiate your way through and to convince senior management to accept some of your recommendations. You need to have business skill. You need to have that domain knowledge. So the understanding of how business works is very, very important. Of course, for some of you that are already working in that space, you can bear me witness. So if you go to e-transact, for instance, one of those things you want to know is how pay outlet works. If you go to maybe InterSwitch, for instance, one of those things you want to know is how VAV work or how MasterCard business, how it works. Yes, if you go to maybe FCMB Bank, you want to know how retail banking works. All of that are all very, very relevant um, they are all very relevant in big data as a big data practitioner. Yeah. So what is the future of big data? I can tell you the market size is not shrinking at all, even despite COVID-19, because as we continue to generate more data, there is still going to be a lot more need to understand. There's going to be need to understand what is happening to the data. And because you want to understand what is happening to the data, you need a big data practitioner, or you need big data analysts to help you to look into the data set, you know. So because of that, as we generate more data, and there is this saying that the data that has been generated in the past 2 years alone is more than all the data that has been generated maybe in the past 15 years. And if you look at the chart in front of just the chart in front of you, you see 2019 and 2020. If these are the data sets that have been generated in these 2 years, if you combine them together, they are more than all the data sets that have been generated between 2018, 2008 and 2018. And that is even more reason why you now need experts that can look at this data set and this trend and then make inferences from them and make recommendations for businesses. So yeah, I think that is just about that on the introduction to big data. So today we are going to be looking at the business applications of big data. So let's take a closer look at some of the applications of big data. Although maybe we mentioned some of them in the previous session, but we are DASCA is allocating a full class to those business applications of big data. So let's look at the objective of today's class is to describe the significance of social media in the context of business. So when we talk about social media, how can you leverage social media in the context of business? So before now, if you notice, for those that have been going out, around Yabatech, there is a billboard by Yabatech, by the fence of Yabatech. That billboard has been off for a while now because people are no longer on the road the way they used to be on the road. And because people are no longer on the road the way they used to be on the road, why do I need to spend money on billboard when I can spend that money in digital campaigns? So billboard business is already dying. So people are now social media in order to do their campaign. Now, another example, they are repairing Third Mainland Bridge. So some part of Third Mainland Bridge is no longer available. So for those that ride through Third Mainland Bridge, there is one Airtel billboard at a particular part of Third Mainland Bridge, towards Yanoworo. That billboard, I think I was looking at it on Sunday and maybe sometime within the week. That billboard has been off for like almost a week now. And maybe throughout the lockdown too, maybe it was off because, businesses are now going from that brick and mortar physical infrastructure to the online space, So we are going to be looking at the significance of social media in the context of business. Then we also look at the application of big data in fraud management, especially in financial sector. I'll give you some very fantastic examples. Then also in insurance business, fraud is also a common practice in insurance. In fact, I saw a video recently, I think a video, yeah, of a lady that was charged to the court. This lady took knife and she cut her hand just because she wanted to claim for insurance. She really cut her hand, because she wants to file for insurance claim. And I don't know how the insurance company detected that it was a fraud, that she actually cut herself in order to be able to claim for huge insurance. She cut like her wrist, she cut her wrist away. So you can imagine like in Nigerian space, the kind of fraud, the insurance fraud that may be happening in that space that may even go undetected. Big data and analytics can be applied in order to discover some of those fraudulent transactions. Then we also look at big data in the retail industry space. So let's quickly let's quickly look at it. Um, so this is something that you guys are very conversant with. If you go to, if you're on LinkedIn, at times LinkedIn will recommend some people to you, will ask you to like them. Why LinkedIn is recommending that you should like those people is because of the fact that, see, in your connection, these people, they also have friends within your connection. So why are you not their friend? Because they have seen that within your connection, maybe you have like 500 friends on LinkedIn, and out of those 500 friends, you and that person that is not your friend, you have like maybe 34 people that are mutual friends, you know. So LinkedIn will come and recommend that, okay, why not make this person your friend? You know, that is also applicable in marketing. The fact is that if you like a product, for instance, if you like a product, another person in another person that is in another network within the social media, there's another network that is not your friend, but that have the same set of friends with you, or a good number of the same set of friends with you, would also likely like the same product, that same product that you like. So that is one classical application of social media data. I will tell you how we apply this in telco. For some of you that don't know, so at times when you call your mom, before NCC stopped this, I think NCC have really they came up with a regulation to stop this. So if you call your mom, for instance, you just say a ringtone, then you'll be wondering how on earth will my mom, dial this short code to download this tool. There is no way my mom would do this. So what the telco guys do is that they do what they call social network analysis on all the subscriber bases they have, or their subscriber base. So if they have like a 70 million subscriber base like MTN does, within that 70 million subscriber base, that means it's a network. So MTN is like a network of 70 million people. They are all connected. So one person is connected to another, they are all connected in some ways. So you have 70 million people. But within that 70 million network, you are going to be having, so imagine this picture is that MTN network of 70 million people connected. But within it, you are going to be having smaller groups, smaller networks here and there, smaller networks, smaller networks, smaller networks. Within that smaller network, there is going to be someone that is a leader of that network. There's going to be someone that is a follower in that network. So what MTN will do, or what telcos will do, that on who is the leader of that network, they will put a free ring back tool on that person. Once they put that free ring back tool on the person's phone, they know that other people within the network are likely going to reach out to that person and call the person. And because they belong to the same network, and if they like the same set of things, if they belong to the same network, they will most likely they will most likely share the same value and like the same set of things. So when they give that feeling back to on the leader of that network, when the followers in that network, when they call the leader of that network, when they hear this tune, they'll say, oh, what a nice tune on my pastor's phone. They'll just click one, to copy. They can just click one to copy the tune. So that is one way that they market their product in the telecom. That is one of the ways they market their product in the telecom space. And I think that is a very good one. The same is applicable Facebook. Facebook also does the same thing. Facebook will tell you that you are mutual friends. That why not like this person? So it's applicable. So you can take that into your business, your network. You have a network. Another friend has another network. And then you guys independently begin to see that you're having the same set of people in common. So you can leverage this and monetize it in a way that can add a lot of value to your bottom line as a business owner. Please, if you have any question, please. Okay, let me pause a bit so that it will not be one way. Let me pause a bit. So please feel free to ask me some question. Please, can you please ask me some question before we proceed? I need one question before I proceed. Is it clear? Is it not clear? Please let me know so that I can proceed, or I can probably make it not. Hello, am I the only one here? Please, someone should just say something. Just say something. Okay, so maybe I should ask a question, or maybe I should ask a
For
question.
me,
I'm
I
going to
think
ask a
it's
question
clear.
very soon. Oh, okay. What did you say, Petra? Am I still connected?
Yes, we're
Yes,
connected.
okay.
Okay, thank you, thank you. So when you look at social media network, it's applicable in product design, it's relevant in marketing, it's relevant in PI, of course. It's definitely relevant in business intelligence. You know, business intelligence has to do with knowing about your business, about what your customer wants, what your competitors are doing out there. You know, so social media network can help you to have intelligence in terms of what are your customers doing. There's a project I gave to the graduate guys where we do bank mobile app analytics. So different banks have different mobile apps. So if people are having difficulty with those mobile apps, they'll go to the comment section and they write their review. They write their review right away. So can we put all the banks app? Can we put them side by side and then review all of them, and tell you which of the banks is better or has a better digital platform? You know, that is business intelligence. So if we know the bank that has a better digital platform, we can probably go and copy them and paste what they have done in order to also like copycat them, you know, without necessarily reinventing the wheel. That is business intelligence, and that has to do with extracting social media data, you know, reviews and comment that is written about a particular app, or maybe Twitter or LinkedIn or Instagram. Then in marketing too, when you want to market your product, it's very, very important. Like, of course, like I'll tell you, GT Bank has 6.2 million followers. So what on Facebook, not to talk about Instagram and Twitter. So what it means is that GT Bank can just make a flyer today. They can just do a flyer today and post it. They are guaranteed that at least people within their network are going to see that poster that they have made. But before now, in the era of TV and radio, you know, how can they even guarantee that they will have a listenership of 6 million, you know, or for a radio program, and that they will even spend a lot of money. But this one, they don't even spend a lot of money. They just need to look for their content creator to just create a content for them. Once the guy create a content for them, they will just put that content on. They just post the content on their social media page, and they've done their marketing, and money is coming in. You know, we too also do it in Octave Analytics. You know, then you also have product design and development. We want to create a new product. You can go and do sentiment analysis, go to the social media data and analyze the comments, what is trending, what people are saying. Based on that, to come to the development room to develop a product that is suited to those comments that people are sharing on the social media space. You know, those are some fantastic applications of social media data in the space of maybe business intelligence, or in product development, or in marketing. So yeah, so some of these slides are just explaining some of those things that I have said, but I'm trying to contextualize it in our own local environment. I'm trying to bring it home in our own local environment. You know, let's go forward. So the other aspect is big data is also applicable in detecting fraud. You know, credit card fraud, return fraud, personal information fraud. So maybe some of these examples may not be totally relevant in Nigeria. But I'm sure I know that some people are planning to travel to Canada, some people are trying to travel out of the country. So let's talk about credit card fraud. There is a guy they call him Invictus. Obi Invictus. And there's Hush Puppy. Hush Puppy. There is something that I decided to call Hush Puppy analytics. Of course, it's definitely true analytics, data analytics that is through some analysis of data. That is how they try to track some of these fraudsters. If you follow the news, Hush Puppy was caught, by analyzing some of his social media posts, and the law enforcement agent just picked interest in him because of the social media posts, and then they started tracking him, they started following him, they started connecting to the people that are his friends on social media, they started commenting on the social media space as if they are his followers, but they are not his followers, they are just investigating him, they are trying to track him and trying to enter his network and link up with other people that are fraudsters within his network. So these people, when Hush Puppy and his cohort, what they do is credit cards, they do credit card fraud or they do internet fraud, by posing to be other set of people. I'll give you one very valid example. It, it, in Nigeria here, when somebody's ATM card is stolen at gunpoint, what the criminals do is that they at gunpoint they ask for the person's PIN. Some of them even have a POS. Some of them have a POS machine. Is anyone saying something? Please mute your microphone so that there will not be feedback. Okay, so as I was saying, so when they steal someone's ATM card, they insert it in POS to confirm the person's PIN. So after confirming the person's PIN, then they will now go to the nearest ATM machine. They will go to an ATM machine and then they withdraw the limit, the credit limit for that person for the day. And they do this around maybe 11 p.m. in the night, so that by 12 o'clock, so the limit for that day is exhausted. Then by the following morning, they go again and start withdrawing money from the person's account. But when you look at it, all of this can an intelligent ATM machine can actually track this. An ATM machine that is intelligent can tell that the person that is using this card, he does not have this type of transaction pattern. Most of the time when he withdraws money, he only withdraws 5K or he withdraws 10K. The last time he withdrew up to 20K, it was not this ATM that he used, and it was around this location that he withdrew that amount of money. He withdrew that money around a location that is close to a mall, and it was during the daytime, it was not around 11 p.m. So for somebody to be withdrawing his credit limit around 11 p.m. in the night, no, I think this is a fraudulent transaction. Then let me swallow the card. You can swallow the card as ATM, or just put a second level authentication on that card. You can put a second level authentication on the card in order to make sure that the person that is using that card is actually the owner of the card. That is, that can be coded into an ATM machine in order to prevent fraud. So in financial institution, big data, and that will have to do with analyzing ATM transactions. For those that have worked with ATM data before, the ATM data is huge. It's one of the huge data sets. So imagine building that model that be able to leverage the data, all the data set, and leverage the technology in order to be able to cut, to predict fraud and then to stop fraud. That would be something that is very relevant in Nigerian market. Then also, Okay, so I want someone to give me an example of in online business, in online business like Jumia, Konga, kind of business. I want someone to give me an example of how big data can be applied, to detect fraud in Jumia. After Jumia was listed on New York Stock Exchange, I think they had some very big issue where they discovered that some of the transactions that were reported in Jumia, by some merchants, they were actually fraudulent transactions. So is there a way that big data could have helped to identify those fraudulent transactions? I'm throwing this open to the house, and I want to hear comments and feedback. So maybe I should call him. Petra, are you on the call? Yeah, Petra, over to you. So how can big data help to identify fraud in online retail business?
Okay, so I think they will start by understanding the behavioral pattern of their customers, maybe putting them in segments and having a behavioral pattern for them. Then, if anything goes outside, very absurd from what those sets of customers do over time, then we can now maybe draw a flag that something is different from what we used to know. I don't know whether I answered the question.
No, I think I put it in context. Put it in some kind of context. Maybe, have you ordered something on Jumia before, and the product that they deliver to you it's subnormal, it's abnormal, it's not anything close to what you opted for. Is there a way you could have detected that? Is there a way that we can use big data within maybe your GG platform or Checky platform or Konga platform to detect that some of the items that they are selling on that platform, they are stolen platform? Is there a way? So put it in context. Give us some examples, real life examples.
Okay. So we are talking about like the people delivering are the one having the wrong product, or the people who actually sell are the one having the wrong product.
Just whichever way, both
Whichever way.
are valid. Any of the two is valid example.
Okay. So on these online platforms, there usually are records of those stores, and they have the records of those people that sell on their platforms as well as the delivery guys. So they can be traced to understand the patterns of let's say a delivery guy now who actually delivers for there's a message you're supposed to Jumia actually sends a message or Konga anyone whether you're satisfied with the product or something. So I think that message goes back to their own database where they are able to understand whether you're satisfied with the product or not. So if such trends happen where they try to correct certain things over time and such things happen around that particular channel, then they can raise questions.
Okay, thank you. So thank you very much, Petra. Thank you. Um, okay, so I also want to. So the question is still on the floor. I want to also get crowdsource some solution. I need some more example. Ayola, can you give us some classical examples of how we can apply big data, in detecting fraud in retail business?
Um, in detecting fraud in retail business,
Yeah.
looking at I'm looking at, for example, the merchants. We can look at their display pictures. because some of them, they use borrowed pictures or they use stolen pictures as their display picture. So if we if we if we are able to like
Okay, thank you. Can I help you?
yes, sir, please.
Okay. Okay, thank you. Thank you. So if you don't play in that space, the truth is that if you don't play in that space, it will also be difficult to come up with some of those use cases. You know, I think Takwe is unmuting her microphone, so I'm going to allow Takwe to give us an example.
Okay, so I don't really know much about the retail sector, but I'm thinking of some cases that happened to me personally, and so I bought something on eBay, and I wanted to buy a textbook, and after scouting eBay for of course on Amazon it was very expensive, so I decided to go on eBay to buy it, and after I contacted the merchant and we agreed, and they told me to use my PayPal account, immediately I got an email from eBay telling me that the merchant is, well, it wasn't immediately anyway, let's just say after 30 minutes before my payment was being processed, I got an email from eBay telling me that this merchant is fraudulent and he's been linked to fraudulent activities, and that they are sorry that I got this kind of service on their platform, and that they will refund my money and blah 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 blah. So that's one case. I also had the case where my credit card was being used for fraudulent activities when I went to a gas station. So I think if we want to look at some use cases, it's not only about how they detect fraudulent activities on their platforms. Now that I'm talking about, I want to just use the cases of e-commerce as an example, but it's also about how fast they can detect some of these fraudulent activities. Because I think in my case, or in my scenario with eBay, I could have actually gotten swindled out of my money. They contacted me 30 minutes after I had contacted this merchant on eBay. So of course they can have some platforms that they can put they just put in place to ensure that if they're even detecting, when they are detecting fraudulent activities, of course it also has to do with probably some machine learning models. Maybe they train some data set and just to detect any unusual patterns, especially among their merchants. But it's also about how fast they can detect it so that they can warn their customers. For Jumia, I've bought a lot of horrible stuff that is so not substandard stuff, that is not what they display. So I think a lot of sentiment analysis, especially when it comes to the ratings, because that also can help. Sometimes they say, oh, how was this product? Can you rate this product? What was your experience with this product? So when they hear people's feedback, I mean, they can like do some sort of sentiment analysis so that they can understand that, okay, this merchant is always associated with substandard products, and they decide that, okay, this person should be booted out of our platform. So it's about the will I say, the techniques they use and how fast they can deliver those techniques. I don't know if I've answered. I tried as much as possible. I don't know if it's
Thank you, everyone. Thank you, Temitope. Thank you. I have nothing to add. That's exactly spot on. I'll give you one more. I'll give you one more example in another industry before we move on. So in insurance industry, there's a lot of fraud that happen in insurance. And if you have a good understanding of how insurance business works, you can cover you can buy a cover, an insurance cover, to protect, to protect a product, or to protect a valuable item from unforeseeable or from uncertainty. So for instance, you buy a car, maybe there is going to be theft, or there's not going to be theft, or maybe there's going to be fire incident, or there's not going to be fire incident, or maybe there will be accident. So you can buy a comprehensive cover on the car. So we've seen cases where people buy insurance cover, and maybe because they are broke, because they are broke, they can go and file for theft. They can claim that their car was stolen at gunpoint. They went to maybe a nightclub and the car was stolen, whereas the car was not actually stolen. Maybe they only asked somebody else to come and take the car and go and park the car in a different location, and the car is going to be there for a while they are processing their insurance claim. What they are trying to get to is to get the insurance company to pay them some claims, for the car that was stolen. And usually it can be a lot of money, because it can be something that is enough to buy that car, less depreciation of the car. So is there a way to predict that a customer, at the point of underwriting an insurance business, is there a way to predict that that customer is going to file for claim? Yes, you can build a model that can tell you that, because again, there are people who have filed for claim in the past. The people that file for claim in the past, they will have some kind of characteristics. Maybe they belong to a particular age group, they work in a particular industry, they came from a particular broker or from particular agent. They went from the questionnaire that you give them to fill, they answer those questions in a particular way. When you analyze all of those historical data for all the people who have filed for claim before, based on that, you'll be able to tell that if for this new business that you're about to underwrite, the chances that this guy is going to file for claim is maybe 50% or 60% and the rest. So you can build a model that can predict that a client is, that a customer is going to file for claim. Even at the point of underwriting that business, you've not taken the business yet, but when you see that business that you want to take and you compare it with all the businesses that have filed for claim, you can probably tell with some level of confidence that, there's a chance that this guy will file for claim. So I'll give you how they do that. With intuition currently. So imagine if Nigerian police, take their vehicle to custodian insurance, and they want to insure that vehicle. Within a year, what is the chance that the Nigerian police vehicle will be involved in an accident? Whether it will hit somebody or somebody will hit it. So the same way, and the way they drive those vehicles. So there was a time during Obasanjo's time that they now gave police ASPs and above, they gave them vehicles, they gave them official vehicles, very fine vehicle from Pojo. I learned, those times I was also working in insurance company, I learned from my colleagues that the claims on those vehicles, because the police guys, the way they drive police vehicle is in a rough way. So that same way is also the way they drive their own personal vehicle. So if we have aggregated the data from all of these people, all from maybe across all the whole industry, then it will be able to guide us to tell us that, for this guy that is working in this particular sector, the chance that he's going to file for claim is very, very high. Then also, I think also, so another thing they do in insurance company, for vehicles that are used for commercial purposes, like all these God is good motor, the premium that they pay on those vehicles, they are higher than the premium that you pay on your own private vehicle that you just drive to the office, you leave it in the office, in the night you drive it back home. The premium on those vehicles is a lot higher than the premium that you pay on commercial vehicle. And then the premium that they pay on some luxury vehicle like Bentley or Rolls Royce, the premium is there's a different way they also compute it. Because those vehicles, the people that own those vehicles, they only go out with them once in a while, and the value of those vehicles are very, very high. And the chance that robbers will go and rob those kind of, vehicle, the chance is very, very slim that robber will go and rob a Bentley, or we go and rob somebody that is driving a Rolls Royce, because even the Rolls Royce is going to be going in a convoy, and that Rolls Royce already has security escort in the front and in the back. So the premium that they pay, they normally reduce the value. You know, the percentage is usually very, very less, because those vehicles, they really involve in claim issues from their historical knowledge. But all of those things, they are not documented. They can be documented. So that knowledge can be documented into a model in order to help new people that are probably coming into that space, and they want to build model for detecting fraud in insurance. Then so as I said earlier on, we can detect fraud in insurance by looking at the patterns of the historical record of people who have filed for claim. You know, by the time you look at those patterns of those fraudulent claims, we can tell that this claim that a customer has filed after he has an accident, the location, the timestamp, the duration between when he did the underwriting of that business, and the relation between when he did the underwriting of that business and when he filed for claim. When you relate all of that together in a very intelligent way, you'll be able to identify predictors, very strong predictors, that will tell that a claim is a fraudulent claim or otherwise. So why we spend time on that is, of course, you may also find yourself in an insurance company tomorrow. Just make sure that you'll be able to relate what you have learned to whatever they do in that industry that you are hoping to be offered an employment. Then also, traditional methods of detecting fraud may have some limitation. In some cases, they can be cumbersome. You know, at times, in many cases, they rely on maybe intuition. They rely on experience. You know, so that knowledge that is inherent in that intuition can be coded into a system. You can codify it into a model. You can codify it into a model in such a way that for somebody that does not have such experience can apply that model on a set of data sets in order to determine whether a transaction is fraudulent transaction or otherwise. So some of the method that they use to detect fraud is social network analysis, predictive analytics, and customer relationship management. So under social network analysis, you see people who, okay, so I'll give you this example again. So some time ago, my wife's phone was stolen in Unilag. My wife's phone was stolen in Unilag. So we waited for a long time until that phone was detected on MTN network. But before then, my wife was using a Glo number, so we could not detect that phone on Glo. My wife was using Etisalat's line. So, but we could not detect the line, the stolen phone, we could not detect it on a Etisalat line because they removed the SIM card. Then it took maybe about 3 months. After 3 months, the phone came up on MTN network. We just detected that the phone is on MTN network. So we took the phone number that we saw on that IMEI. All phones have a unique IMEI that identifies that phone. So for your phone, when your phone latches on the network, they can tell the IMEI and they can tell the phone number that is on that phone at that particular point in time. We took the phone, we now went to Truecaller. We translated the phone number to a Truecaller name, to the Truecaller name that we saw on Truecaller. Then we now took that Truecaller name, we now took it to Facebook. We now profiled that person on Facebook and befriended the person on Facebook. The person even happened to be a 300 level student in Unilag. So we are trying to unravel fraud. We are trying to investigate fraud. And what we are using is data from Truecaller, data from Facebook. In fact, we knew that that person finished from a school in Lagos. We knew the secondary school the person finished from, the year the person gained admission to Unilag, the department the person is in the Unilag, you know, the hostel where the person is in the Unilag. From the profile picture, we could tell. So it was very easy to catch the culprit. We just like designed the package. We said that there's a package from DHL, and we are not authorized to open that package. And that package it's for her. You know, that is she not in this department? Is she not in Unilag? That is the address that is on the package. So what we've done is that we are using social network analysis to detect a fraud, you know, that has been committed. And if, for instance, if it's like a gang, maybe it's a network of gangs, like they did for Hush Puppy, we could also maybe take some extra time to also break into that network to know all the people that are affiliated in those kinds of fraudulent transactions. Do they have a kingpin? Do they have a sponsor? Who do they sell the items to? By the time they steal the item, who are the people that buy those items, and so on and so forth. So social media analysis is very, very relevant in detecting fraud. Then also predictive analytics. So predictive analytics, as I said earlier on, somebody is filing for claim. You know, somebody is filing, you know, somebody wants to underwrite a business. At the point of underwriting that business, the guy has not even filed for claim yet. But you want to tell that, this person, what is the chance that this person will file for claim? They have generated some patterns that over time, that pattern, so it's not just spontaneous. They are not just behaving spontaneously. There's a pattern that they generate. For those people that have maybe that have gatemen in their houses, you notice that when your gateman is leaving, the gateman will come and say, my wife put to bed, and tomorrow is naming ceremony. For all of them, they have that same rhyme. And now one can come and say that I'm going back to my work that before I used to do maybe weather work before, but because I didn't have money to buy equipment. So all of them, like maybe my house have had like maybe up to like 10 different security men plus my former office where I work. All of them, by the time they are going, they will come and tell you one story. And why they are telling you that story is that, okay, if I take 2,000 from this guy and take 5,000 from that guy and take from like 10 people that I know, at least I'll be able to raise 50K before I leave this particular location and go to another location. That is the style that those guys have formed. So all of this can be coded into some knowledge base, you know, in form of a big data model. Yeah. Then also for social customer relation management. So for customer relation management platform, some of these can be analyzed in a way that can help us to detect whether a transaction is a fraudulent transaction or whether it is not a fraudulent transaction. Please, is there any question? If you have any question, please feel free to ask me if you have any question on all of that we have discussed. Do you have any question? Am I still connected? So let me be sure if I'm still connected. Am I still connected?
Yes.
Yes, you are.
Okay, thank you very much. So I think there is actually no limit to the applications, to all the applications of big data. I just pick a particular industry, pick retail industry, pick insurance industry, banking, oil and gas. You can just keep on going on and on. As long as it generates data, even in accounting, as long as you generate data, there is always one application, one particular specific use case for which big data can be applied. So let's go to let's close today's class by looking at the different technologies for handling big data. So as I said that when a car breaks down on third mainland bridge, there's
Sorry,
a
hello,
special
Blessing.
vehicle. Yeah, okay, hi. Pushing on.
Yes, sir. I'm trying to think, is there a way, because we talk about big data, and then it's more like it favors these guys mostly, the top guys that have accumulated data over a long period of time. I mean, how do small businesses leverage on this new hype and so?
Okay, thank you very much. So I get that question a lot, and I love that question. I get it a lot. So a senior manager in MTN called me on Saturday or Sunday. He said to me that it's, that there is a facility management company. So that facility management company also want to go, they want to apply data analytics and big data into their operation. So that Blessing, how do you think that this can be applied? So I'm sorry to say, it's not all. Analytics maybe can be applied to every industry, but when it comes to big data analytics, if you don't have data at a particular level, if your data, the volume of your data does not get to a particular threshold, then it is not big data analytics. Maybe it's just data analysis that you are doing. You know, there are some companies that all of their data sets, you can load it on a spreadsheet. Yeah, there's a company in Lagos. Maybe I just want to call the name of these companies, because I feel I'm safe here. Cars 45. So Cars 45 said that they want to hire a data scientist. Or they need some data science services and stuff like that. So we asked them, okay, how many customers, Car 45, how many customers do you have, all since inception to date? They have 27,000. It's 27,000 for like 3 years or 4 years. They have 27,000 customers. And what they collect on those customers is just the name of the customers, the type of vehicle the customers have, the amount they decide to buy the vehicle from the customer, the color of the vehicle, like maybe 5 or 6 rows, 27,000 record. And they said they want to hire a data analyst. Data analyst, what do you want to hire that data analyst for? This is Excel. This is Excel sheet that you want to be working on. So this is not big data. So even some of those models that we are talking about, it will be overkill for them, because what exactly do you really want to predict if you can basically use Excel to analyze that data and to see some trends and patterns in the data? So to answer your question, for small businesses, if your data volume does not get to a particular threshold, I'm sorry, that's almost like big data. It's okay. So this is the way it is. This is the best way to answer that question. You want to travel to Abuja. You want to travel to Abuja with your friend, just 2 of you. So 2 of you decide to take a BRT bus, and you drove a BRT bus to Abuja, because even though it's just 2 of you, so it's more or less like applying big data on a retail business or a small business that does not generate so much data. And that goes back to the example that I said, that for different types of data sets, there are different types of tools that are required. So when data is not big to a particular limit, then applying some of these big data technologies and big data techniques would be like an overkill. It would be completely irrelevant, or it would be like a waste of time. It's probably not required when the data does not get to a particular threshold, So, but the question is that what is that threshold? What is that threshold? That is the question. What is that threshold? It's a difficult one. It's a difficult one. But how you will know is this: the volume is large, the the data has a lot of varieties. So it's not just maybe 5 columns. Maybe the data set is having up to like maybe 200 columns or even 100 columns, in a way that it becomes cumbersome when you're using when you're analyzing those data manually. It becomes cumbersome. At some point you get lost if you're analyzing those data manually. So that's it. Then it comes in varieties, volume, value. It's voluminous, as in the size is substantial, and volume, velocity, and it's changing very fast. Yeah, that's the other part. It's also changing very fast. At that point, when you have data in that way, so in the bank, if you look at the kind of data they generate in the bank, it's a big data. It's an example of what we call big data. In telco space, you have a company that has 70 million customers. Maybe 35 million of those customers make a call in a day, and maybe they make up to 5 calls in a day, and they receive up to 10 calls in a day. So imagine that is like 15 entries times 35, apart from the data sessions that they are generating. When you look at that, that is huge. But for a small business that only keeps small records, it may be they will need to keep that, they will need to be collecting that data for a very long period of time before they can now start mining it in using some of these big data tools. I don't know if that answers your question well. How would you summarize my answer?
Yeah, we would accept it that, okay, big data is not for small businesses.
Are you saying small business? Maybe we should say, maybe we should put it in a different way.
Okay.
How would you rephrase? So Uber can be a small business compared to Microsoft, but Uber can be a small business compared to Microsoft. So let's not say small business. Maybe for businesses that are not generating a whole lot of data.
Not data. Okay, fine.
There you go.
Yeah, thank you.
Okay, so let's look at some of the technologies for handling big data. And the fact that data itself has evolved from what used to be small data to what we currently know today as big data, for what used to be slow data to what we now know as very fast data, to what is now known as data that comes in variety. So this will require different kinds of tools to manage or to handle those data sets. So in this section, we'll be looking at the different tools or the concept of distributed computing. So there's a concept of distributed computing. This is a computer science concept, but it's something that it is good to know, because for some of you guys that go to site and work in a site, you hear them, they say that they want to migrate your server. They want to migrate your server from one virtual machine to another virtual machine. Or some of them, at times they'll tell you that they want to do virtualization on your server, or they want to create virtual servers for you. So what exactly is this virtual server? What is the concept of virtualization, distributed computing, parallel computing? Those are some of the things that we are going to be talking about here. They are technical, but it's good you know it, so that at least you'll be able to engage when you are in the committee of data scientists. Then we'll take a broader look at Hadoop technology and the distributed architecture of Hadoop technology. Then we'll talk about cloud computing and how cloud computing is best suited for big data analytics. And if also time permits us, we'll look at what they call in-memory computing. I love taking this class in the physical environment. And why I love taking this class in the physical environment is that in a normal class, this will require me drawing diagrams on the board. With those diagrams, you are going to be able to assimilate the concept a lot better. And it will require me to take you through the architecture of computer, the different components of a computer, the memory of a computer, the hard disk drive of a computer, the central processing unit, the processor of a computer, how they are connected, and how they can be reconnected in a way that will facilitate distributed computing. But I hope you find it interesting as we proceed. So we'll be talking about, let's start with the concept of distributed computing and parallel computing. So there's a diagram in your textbook. If you have your textbook open, I think it's page 57 or thereabout. But I'll soon navigate to that page that has that particular picture in your textbook so that you can be on the same page. So when we talk about distributed computing has to do with multiple computing resources that are connected within a network. So say there are 5 of us in this class now, there are 6 of us in this class. We can connect our computers together in a way. We can connect our computers together in such a way that if you have a task, all the 5 computers are going to perform that task together instead of having only one computer performing that task. So for instance, there are times that Pushimo will be running some queries, and Pushimo will say, that query, normally if I run that query, it will take like 30 minutes for that query to draw, or it will take like 2 hours for that query to draw. In a distributed computing environment, the process that computer is performing, that it will take maybe 30 minutes to execute. In distributed computing, there are tools that will share that task among all the computers that are within the network, and all of those computers will perform their own bit, and then they will combine the results in a way, and instead of it to take 30 minutes, it will just take maybe like 5 minutes to get it done. That is the reasoning that resulted in distributed computing, that what one man can do in 3 days, it will take 3 men only 1 day to get it done, or it will take 1 day for 3 people to get it done. So computer or computing itself has to do with 3 resources. There are 3 resources that we try to manage in computing. Number 1 is memory. Memory is the memory. Number 2 is the processing speed. Number 3 is the storage space. So I want you to note this. So when you say Pentium 1 or Pentium 2 or Pentium 3 or Pentium 4, when you say Core i1 or Core i2 or i3 or Core i5 or Core i7, what that is differentiating, it's actually differentiating 3 things. It's differentiating the processing power of the computer, it's differentiating the memory space that is available in that computer, and it's also differentiating the storage space. Memory is different from storage. The storage capacity is different. So I wish I can draw on the board. So when you go and buy a computer, most of the time, what you are trying to negotiate is all of that. Even when you are trying to buy a phone, whether it's an Apple phone that is 64 gig will be more expensive than Apple phone that is 32 gig, because that 32 gig is the memory space, so it can contain more memory, and then there is the processing speed too. Like when you say 2.5 gigahertz or 3.4 gigahertz. So those processing speed determines how fast the computer can execute your process. So now imagine you now have 5 slow computers. If you have 5 slow computers, if you connect them together in a distributed network, this is a research work now. If you connect them together in a distributed environment, it is believed that those 5 slow computers will execute faster than one single computer that has a better speed than any of those 5 slow computers. So another way, Mr. Philippe Megwari is a research paper that he wrote probably long ago, maybe 1990 something or early 2000. He said that if you take like maybe 200 chickens and you tie them to a cart and you ask them to run to maybe from Lagos to Ibadan, for instance, those 200 chickens, they will be able to pull that cart and they will pull it in a very efficient way, and they will even run faster than only one horse pulling that cart from Lagos to Ibadan. You know, it's a research that is documented, you know, and that is the concept, that is what led to the concept of distributed computing. So within the distributed network, it's usually faster, it's more efficient than the traditional computing, you know. And if you want to carry out complex operation, so instead of asking one person to do it and that one person would die in the process, why not share it within a set of computers that are interconnected within the distributed network, you know. So one advantage of distributed network is that if you break it up, if you disconnect one computer within the network, it's still not going to stop the work. The work will still execute. The other subcomponent of the network, they would execute their own task and return the result. So instead of the whole work, you know, crumbling, or instead of the whole work getting terminated, it's probably the only one it's only the one that's affected by the node that is down that will be affected, you know. So breaking all of the tasks into subtasks and carrying out subtasks simultaneously can significantly help you to speed up the execution of whatever job that you have applied to distributed computing. And that is why you wonder that what kind of computer is MTN using that if 200 people are making calls simultaneously, you know, all of them can be talking at the same time and they are receiving at the same time. What kind of computer are they using? I wish we can do an excursion and I will just take you to MTN data center. You see distributed computing, like live operations of distributed computing. And that is the same thing that guys like Google that they are using, guys like Amazon Web Service, guys like Microsoft, that's the same technology that they are using that makes it possible for you to go to Google and you search for an item on Google and then it returns the result like almost in a twinkle of an eye. You know, within a microsecond, Google has returned your result for what you are searching. It's because your query to search is distributed. The job for what you want to search is distributed among multiple computers, and all of them will return the result and they will combine the result. And so if I want to search for, say I want to search for Blessing Oladiji now, Blessing Oladiji. So I'm searching for Blessing Oladiji. You returned 160,000 results in 0.64 seconds. And some of those results, some of them are on Twitter, some of them are on Instagram, some of them are on LinkedIn. He went to different computers and brought out all of those results and is presenting that result in one single space. So let me say I want to search for food. I want to search for the word food, for instance. I'm searching for the word food. So food is returning 8,830,000,000 records in 0.65 seconds. How is a computer able to search for an item, is searching for a keyword that is returning 8 billion results in less than a second? What made that possible? What made that possible? Guys, look at what I'm seeing. Your Blessing Food Canteen. Wow. Just search for food. It's returning Your Blessing Food Canteen. Okay, nice one. You need to find where this Your Blessing Food Canteen is and go and eat their food. Okay, so coming back to what we are talking about, distributed computing that made that possible for us to be able to get such results in a very short time. So the query to search is sent across a number of different computers that are connected within the network, within the internet network, and all of the results is collated together and combined, and the total is presented within 0.65 seconds, and you can see the result. Please, do you have any question before I proceed?
That's fine, sir.
Okay, thank you very much. So one thing about distributed computing, you know, even though I said that when you have multiple computers connected together, even though those computers are slow, the combination of all of their power and all of their processing power will be able to get things done faster than if it was only one computer that is doing all of that work, you know. But the greater the processing power, the faster the result of that computing. Another way to look at it is like you want to tow a vehicle, for instance. You want to tow a bus. A bus broke down on Third Mainland Bridge, so you brought a towing van, and then you tie that towing van to the BRT bus. Yeah, it's going to pull it. It's definitely going to pull it. You know, with some difficulties, but it will pull it. But imagine you now tie like maybe 3 or 4 towing vans to that one single BRT bus, you know, and those 3 towing vans occupy the 3 lanes, and they are pulling the broken down bus. So you can imagine the efficiency. So the work itself, the load will be distributed across the 3 towing vehicles. The same also happens in computing. So, in comparison of distributed computing with parallel computing, so distributed computing is, as I said earlier on, is a collection of multiple computers that are connected together. But for parallel computing, in parallel computing or in parallel system, that one only has multiple processing units. I really wish I can draw on the board, but I cannot demonstrate this without drawing. I cannot demonstrate this properly without really drawing it on the board. But if you check, just a minute, let me get my pencil. Okay, sorry, my textbook is not around me. So, but there's a page on that textbook. There's a page that has this picture. I want to quickly show you the picture. Okay, so this picture. So if you can turn to this page on your textbook that has this picture, I think it's somewhere around maybe page 57 or page 62. It's somewhere between page 57 and
page 43.
43. Okay, sorry, I'm mixing it up. Yeah. So if you look at this, so this is distributed computing system, and this is a parallel computing system. So for distributed computing system, these are independent computers that are connected together. So if you break this network, the distributed system will still be functional. If you remove one of these, the distributed system will still be functional. But in the parallel system, parallel system has multiple processors, but only one single memory. And remember, I said in the beginning that there are 3 key things that we try to manage in computing, in computer science. Number 1 is the processor and the processor speed. Number 2 is the memory, and number 3 is the storage space. So most of the time when computer is slow, some of the things that we think about is that add more memory to it to make it faster. In some cases, we think, okay, add more processor speed to it to make it faster. In some cases, maybe when the disk is getting filled up, some of the recommendation would be something like, add more, buy a bigger hard disk drive, buy a bigger or buy external hard drive and archive away some of the things that you have. But in computing, three things that we manage is processor, memory, and disk space or storage space. So for distributed computing, it's a collection of computers that are interconnected, while parallel computing is just maybe one single computer that has multiple processors. Distributed computers can coordinate with each other, they can coordinate with each other and they are autonomous. So what that means is that, so this computer now, in this distributed network, if you disconnect one of these from this distributed network, this computer, this one unit of it can operate independent of every other one. And it can also operate together with everything. So they are interdependent. It's independent and it can also work together with every other one. But in parallel system, all the processing units, they share a common memory space. And because they share a common memory space, if this memory is down, if something is wrong with this memory, all of these processors, they will not be able to work. But in this case, if something is wrong with any of these, all of this, the distributed system will still be functional. Then also, the connected computers are loosely coupled and they can access data and resources that are remotely located. So they are loosely coupled. They can, as I said, they are independent and they are interdependent. While for parallel systems, they are tightly coupled. If something happens to maybe one of the processors, it's likely going to affect the entire system. So that is the concept of distributed system and parallel system. But the way they have made it is, in fact, you now have a distributed parallel system. So you can have distributed parallel system where you have computers with multiple processors, but they are connected in a distributed system. The idea is just to make sure that you have more processing power, you have more memory, because the advantage of a parallel system is also that you have multiple processors. It means that you can also process things a lot faster. And this is what informs the idea when you say dual core processor. For those of you that know, that buy computer and say it's a dual core processor, it means that there are two processors in it. In some cases, you have quad core, means that there are four processors in that computer. So the idea there is it's parallel computing that they are trying to implement in those computer systems. But whenever you need to have display systems, that means you are going to have computers that are loosely coupled, connected together within a network, and they are sharing resources, and they are distributing the tasks within themselves, and they are executing their own bits, and then combining the results, to give a solution to a particular task. So okay, so I think I want to stop on this note today, because I think we've actually discussed a lot, from the applications of big data to the technologies of big data to parallel computing to distributed system. I think we should stop here today. So tomorrow we'll start with when you want to perform a complex data analysis. What is the workflow? What are the different steps that are taken in performing a task? So then we'll now look at that, how that is performed in distributed system and how that is performed in parallel system. So that's where we'll continue from by 2 p.m. tomorrow. But I'm still going to be around. If you have any question, please feel free to ask me. If you don't have any question, then we'll see you tomorrow by the grace of God.
Thank you, Blessing.
Thank you, Blessing.
Thank you, Dr.
Thank you, Blessing.
Thank you, everyone. Thank you for coming. And if there's no question, hope to see you tomorrow.
Bye. See you.